In this tutorial, I'm going to show you the very basics of a program known as LoggerPro. LoggerPro is a graphing program that's very powerful, and it's very useful for a lot of the experiments that we will use in this class to determine whether or not two variables are actually related. Now, the way that we can do this is that we first need to understand what we're looking at. First thing we have over here is our data table, and in this data table is where we're going to enter our values that we're going to use. This would be very much like the cells of a spreadsheet. It's just a little bit more user-friendly. And over here will be the graph area that we are going to be working with. Right now you see there's nothing on the graph because we didn't place dots. Now, this graphing program doesn't allow you to just randomly click and place dots on it. That's not what it does. Instead, you place your values over here and it puts the ordered pairs over here. All right, now, before we do anything, I just want to point out where a few things are. Up on the top, we have a series of commands. We'll go through these different commands as need be, but right now we're not going to do much with them. Okay, we also have below it, we have these little smart tools that will be the tools that we will tend to use. When we have sensors connected, we could actually collect data and then we won't even have to manually enter it. It will just automatically be entered for us. But right now there's nothing connected and that's why we can't do anything. So just want to show you a few things about how this data gets in the first place. So for example, let's say that I was doing an experiment in which I was tracking an object moving through time. So what I would do is on my x-axis, or my independent variable, I was tracking time as it progressed. Now, I called it time because that's what it is. I'm going to call it a t. The short name of t is actually just basically the abbreviation, and we use a lot of different abbreviations in physics, but t would typically represent time. And the standard unit for time is going to be seconds, so I'm going to click on that. Okay, I will hit done. And what we see here is it now has entered the word time in it with a unit of seconds. Now the short name hasn't appeared yet, and that won't appear until we actually run an equation, which I'll show you at a later time. Now what we will notice though is that the x that used to be on the graph here is now indicated as time because there is no x variable anymore. Now, in math class, you probably learned that this is the x-axis and this is the y-axis. That's just a generic naming system that math used. You could put any two things here. This could, for example, be the y-axis, and this could also be the y-axis. Now, that doesn't make much sense. So we're going to call this the time axis. And over here, the y-axis, we could also make it the time, but we will not. So what we said we're doing in this experiment is we are going to track something's position as time goes on. So, for example, what I will do is I'll double-click on this, and I will indicate its position. And in physics, typically, there's two different positions that we can use. We can be walking along the x-coordinate system or the y. So we're going to go with the x-axis here. So we'll go x, and its unit will be meters because meters is our standard unit of measurement in physics. So we will hit done. And we will see that we now have a position to go with our time. So for example, let's say in this particular experiment, we saw somebody walking at a time of 0, they were at the 0 position, meaning they were at the starting point. And then 1 second later, they were found at the 2 meter mark. Okay, and then at the second mark, they were found at the 4 meter mark. Now you might see the pattern already that for every second that goes by, we move 2 meters. This is representing a constant velocity. So at the 3 second mark, we would expect to be at the 6. And at the 4 second mark, let's say this person got tired, which would be very quick to get tired, but let's say they got tired and instead of only being at the 6 meter mark, they actually ended up at the 7.8 mark. So they were about 0.2 short of being at the 8 as would have been expected. Now what we see here is that there is a graph that does seem to follow a pretty good pattern that we could predict in the future. Now if we hit this button here, this button will be your friend. It's called the auto scale. Okay, when I click on auto scale, I can see that the points are trending upward in a pretty consistent pattern. Now in fact, at the moment, you can't even see the 1 point because the graph was a little bit bigger than my screencasting video was. So I'm just going to move these over just a little bit to fit a little bit better. Now, what we I'm not going to get too into the data analysis of this, but I just want to show you things that you could do with this. So for example, we have our pattern here. It does have what we would consider to be a proportional fit. I'll show you that later. But if I just were to click on here, if you see these individual points with these circles, you see these tiny little dots on the inside. If I were to click here, double click that is, and I take off these point symbols, these little circles are called point symbols. They're basically locators that let you find your points that you plotted. Now I'm going to turn them off and show you why they're important to have on there. When I hit done, you might not even be able to see this in the video, but there's a tiny itty bitty dot here, 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 and here. and and one up here too. They're very hard to see, so the point symbols become very useful when we're trying to see the data. So that's always something I'd like you to have turned on. Now, in certain relationships, you might also want to connect the points. This is not common. I would prefer you not to do this in most cases, but for this time I will, and I'll hit connect points, and we will see that there is a pattern here that shows that these are going up, and there's a slight bend here. You might not be able to detect it yet, but I'll show you in a moment that it certainly is there. Now, I would encourage not using connecting points unless told to do so, because if I put these in out of order, it would have just played connected dots with the points as they were placed. And what would happen is that instead of just going from one point to the next, it would have been scribbling all over the place, leaving marks as it played the game of connected dots. And then your pattern doesn't actually show up. In fact, what we will show you in a later video is something known as a curve fit. And in the curve fit, we will actually see the real pattern that is formed. So for right now, this is all I wanted to show you. I wanted you to see how you can change up the X, the X label on the data table and the Y label, and how that shows up on the graph. So at this point, at the end of this video, hopefully you can change the names of your axes and label them properly, as well as decide whether or not to connect the points. All right, so again, I will unconnect, and we are done with our first tutorial.